Okay, we're back with part 5 of 9.3. So this time, like I said, I have to remember that we have just strictly less than and strictly greater than. So I have to use a dotted line on these because I don't have the equals on here. All right, so what do we have? I'm going to solve for y, and I'm going to convert it to equals. So I'm going to say x squared plus y equals -5. Subtract my x squared. And so y is equal to negative x squared minus 5. Okay. Now, if we remember our transformations, and x squared is my base, and negative x squared means I'm going to flip it over. So now, instead of having it going up like this, I'm coming down like this. Okay. So that's the first part, is flip over x-axis. And then this part says move down 5 units, okay? And so what I've done then is I'm going to go down 5 units because I flipped down. So I'm going to go down 1, 2, 3, 4, 5. And so I'm going to be here. And so normally it would be like 1, 1. And so now it's going to be coming down like that. It's going to come down like that, okay? And so that's the first one. Now this one, I'm just going to say, okay, that's y equals 5x plus 10. And so I have, and now this one I kind of messed up because I should be doing by, I didn't notice that was a 10 because I don't have 10 things on here, I don't think. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't. All right, so let's erase this. And guess what I did? I drew a solid. Haha. See, I had to erase it anyway, so we're okay. So I have to go down by half as much because I have to be able to get to the 10. So each one's going to be 2. So 2, 4, 5. And so that's where the 5 is. And so I'm going to come down something like that and something like that. Okay. So again, I have to remember those dots. Now I have 10 as my intercept. So I have 2, 4, 6, 8, 10. So that's my intercept. And I'm going to go up 5, right 1. So 2, 4, 5, right 1. And I can go down 2, 4, 5, right 1. And so that's like that. Now, those don't look like they intersect at all. So that's going to be a key, is if there's no intersection, then there's not going to be kind of a solution most likely. And what I have to do is go back up to my initial values for the inequalities, and that's going to help me. So this one I said it should be y is greater than 5x plus 10. So greater than that, that's going to be out here somewhere, okay? So that's going to be greater than, because down here would be less than, but I want greater than, so it's going to be up here somewhere. And the other one, what I did was I solved for y, and so I took that over there. So this one should be y is less than negative x squared minus 5. And so that means it's going to be somewhere in here. Now, somewhere in here and somewhere over here, there's no intersection there. And so, you know, like before, where were they intersecting? That's what we want, is the intersection, because that could be a value that would work for the inequality. But when there's values in here for one and values out here for the other, there's no intersection, and therefore there's not going to be any shaded area. You can just draw your lines and your dotted lines for your parabola and for your line, but then there's not going to be any filling in. So sometimes you're going to have something that looks like that where it doesn't work. There's nothing there. Okay, so basically this one will not equal that one, and we could kind of show you that. We could plug in and say, okay, if we set each of them equal, what would that give us? Well, let's see, would we want to set it equal? X squared plus y and minus 5. Nah, we won't do that. It's not going to help anyway, because it's just going to show the same thing. It's going to be, there's no intersection. All right, what about this one? X squared minus y squared is greater than -4. And so again, remember, we have to have dots. And x squared plus y squared is less than 12. Well, this one I know. That's a circle. And the radius is equal to the square root of 12. Well, that is equal to square root of 4 times the square root of 3. 3. 4 times 3 is 12, yeah. And so that's going to be 2 square root of 3. And so how does that work? Well, basically we have to figure out what is 2 square root of 3 going out. And so 2 times this, well, the square root of 12 basically is the easiest way to do it. Square root of 12 is 3.46. And so I think we can use equal numbers. So 1, 2, 3.46. That would be here. And then 1, 2, 3, and 0.46. Then 1, 2, 3.46. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. And so we're going to have some kind of dotted circle kind of around there. Bad circle, but that's okay. And so this one is going to be a special thing. It's going to be a hyperbola. And we're going to have at the 2's. And so what we're going to do is it's going to be a 0, 2, 1, 2 is going to be a vertex for it. And 0, -2 is going to be a vertex. And then what's going to happen is it's going to come out like this, out like this, out like this, out like this. Okay, so that's going to be a hyperbola. And so you need to kind of know what those are. Again, it's another one of those functions. And with this one, what do we see? It's got to be kind of in between and things like that. And so the circle has to be less than 12. And so in the circle less than 12, that gives it has to be something in this region, something in this region, or something in this region. And with the hyperbola, we're not exactly sure how that one works, but you know, what we need to do basically is test those 3 regions because that's where it says basically our circle is. Now, you know, we could test a region out here, we could test a region over here, we could test a region up here, and we could test a region here. But once we determine that it has to be within that 12, we really only have 3 regions to test, okay? And that's going to help us determine, you know, kind of where it's at. So if we do this one, 0, 0, and so what we have is for, let's say this is region 1, maybe this is region 2, and this is region 3. So for region 1, we're going to do 0, 0, 0. And so if we plug in 0, 0 in this equation, we get 0 squared plus 0 squared is less than 12. 0 is less than 12. Yeah, works there. What about 0 squared minus 0 squared? So 0 squared minus 0 squared, is that greater than -4? Well, 0 is greater than -4, so that's true as well. So we know region 1 works. So let's go ahead and circle, or not with yellow, but with highlighter. So we know that, where's my highlighter at? There it is. That we have this region for sure is going to be there. And usually if one region is true, no other region is going to be that way. So that's going to be our first region. Now let's do test those other 2, okay? So that's going to be 1, 2, 3, so 0, 3, and the other one's 0, -3. So if we plug in 0 for x and this 3, 0 plus 9 is less than 12. No, 9's not less than 12, so that's false. And same thing happens here, that's false as well, because squaring that is going to give us 9 again, and that's not going to be a case. All right, and if we did it in the first one, it'd be 0 minus, and then 9 here, and 0 minus 9 is -9, and that's not greater than -4, it's less than -4. So we do have our final one here, and again, we don't have to choose all these other areas because we can kind of go by this one here, and we know it has to be within the circle somewhere, and so all we really had to do was test those 3 regions. Okay. All right, so that's into part 4 or 5. I'll be back with part 6 on applications.